Welcome to the part 2. Let's start with the example as we promised in the previous video. Simple example to comprehend theory of relativity. Imagine you have a twin sibling, and you both decide to conduct an experiment. Your twin stays at home, while you hop on a supersonic jet plane capable of flying at an incredible speed. You take off from an airport and fly around the world at nearly the speed of light. Your journey lasts for what seems like just a few hours to you. Back on Earth, while you're zipping around the world, your twin is waiting patiently at home. From their perspective, they see you travel at an incredibly fast pace, but they're experiencing time at a normal rate. The reunion. When you finally land and reunite with your twin, you're surprised to find that you're younger than they are. Despite the fact that you both experienced the same amount of time, your high-speed travel caused your clock to tick more slowly compared to your twin's clock on Earth. Explanation. This difference in aging is due to the effect of time dilation caused by your high velocity. The faster you travel, the more pronounced the time dilation becomes. In this example, your supersonic jet acted as a kind of time machine, allowing you to experience a shorter amount of time compared to your twin on Earth. The Miller's Planet Incident. Interstellar's time dilation odyssey. In the blockbuster movie Interstellar, the Miller's Planet scene demonstrates time dilation in captivating detail. As our intrepid astronauts descend to the planet's surface, its intense gravitational field distorts time, causing every hour on the planet to equate to 7 years back on their spaceship. This breathtaking illustration poignantly portrays the power of time dilation. Problem in traveling to past. We have discussed mostly about time traveling to future but not related to traveling to past. There is a problem in that. The grandfather paradox. The grandfather paradox is a classic thought experiment often used to illustrate the complexities and potential contradictions that arise with time travel. Let's dive into it with a relatable scenario. Scenario: changing the past. Imagine you discover a time machine and decide to travel back in time to your grandparents' youth. You accidentally bump into your grandfather at a crucial moment before he met your grandmother. In this new timeline, your grandfather never meets your grandmother, which means your parents are never born, and subsequently, you are never born. The paradox unveiled. Now, a paradox emerges. If you were never born, how could you have traveled back in time in the first place to prevent your grandparents from meeting? This creates a loop where your actions in the past seem to prevent your own existence, yet your existence is necessary for those actions to occur. Parallel universes, solution to past time travel. Imagine you're watching a movie. At a certain point, you're given a remote control that lets you make choices that affect the story. Each choice you make creates a different version of the movie, multiple timelines that unfold simultaneously. Similarly, each action you take in the past could lead to different parallel universes, each with its own set of consequences. You can watch Past by yourself tonight. When we look up at the night sky and observe distant stars and galaxies, we are essentially looking back in time. This is due to the finite speed at which light travels. Light is the fastest thing in the universe, moving at a speed of approximately 186,282 miles per second, 299,792 kilometers per second. Imagine you're looking at a star that is located 100 light-years away. This means that the light you're seeing from that star actually began its journey 100 years ago. In other words, you are witnessing the star as it appeared 100 years ago. Here's a step-by-step breakdown of how this works. Light emission. When a star emits light, that light starts traveling through space at the speed of light. Traveling through space, the light continues to travel through space, crossing vast distances over time. Reaching Earth. Eventually, the light reaches Earth and enters our telescopes or our eyes. Observation. When we observe the light, we are effectively observing the star as it was when the light left it. This phenomenon allows astronomers to study the history of the universe by observing light from distant objects. For example, when astronomers observe a galaxy that is billions of light-years away, they are actually looking at the galaxy as it existed billions of years ago. This provides valuable insights into the early stages of the universe's development, the formation of galaxies, and the evolution of stars. In essence, every time we look at the stars, we are peering into the past, witnessing events that occurred long before human civilization. This concept also applies to other celestial objects, such as planets, moons, and even galaxies that are much closer to us. While we can't change or interact with these distant events, studying the light they emit allows us to uncover the mysteries of the cosmos and learn about the history of our universe. Observing Earth's past with superluminal travel. In a purely hypothetical situation where we could somehow travel faster than the speed of light, we might be able to catch glimpses of Earth's past. Imagine a spacecraft that achieves this extraordinary feat and ventures far beyond the speed of light. As this spacecraft moves away from Earth, the light emitted from our planet in the past would catch up with the spacecraft. Through advanced instruments on board, observers could potentially see events from Earth's history, observing moments that occurred years or even centuries ago. However, this scenario remains entirely theoretical and speculative, as current physics principles prohibit objects with mass from exceeding the speed of light. Conclusion. In the vast tapestry of human imagination, the concept of time travel continues to captivate our thoughts, fueling our curiosity about the past, present, and future. Through intricate discussions and engaging scenarios, we've embarked on a journey through the theoretical realms of time dilation, paradoxes, and the very fabric of spacetime. As we contemplate the enigma of time travel, let us remain inspired by the uncharted territories of scientific exploration. The depths of our understanding continue to evolve, and the mysteries that lie ahead may one day unveil astonishing truths about the nature of time itself. If you've enjoyed this journey through the intricacies of time travel and the cosmos, be sure to stay connected by subscribing to our channel. Don't forget to ring the notification bell, your portal to future explorations and mind-expanding content. Until next time, keep your eyes on the stars and your mind open to the wonders that await.